June, let me get the right date, June 9th, 2020 session of TeamSpeak for Tangerine SDR. My name is Dave, KV0S, and this week I have been working with Red Battaglia a little bit. I have been doing some programming in different spaces. In a lot of what I'm doing right now, it's mixing a little bit of work and a little bit of radio, building base layers that could be used either way. So that's about it for me. Oh, I did get a couple of parts for a loop antenna. I got some PEX and electrical box, so making a little headway. And that's it for me. Next on the list, see, I'll go down. Bill is next. Are you ready, Bill?
Yeah, I've been pretty busy. We wound up putting together an $8 million grant proposal thing, and I don't think that'd be enough money to do what the government wants. But anyway, we got that wrapped up. So after that, I got back to work on the Tangerine SDR stuff, and what I have accomplished in the past couple of days is I figured out the mechanism for how the central control system will request data from the Tangerine. So the way it works is the Tangerine has a heartbeat, and it touches the central control system at certain intervals, which is configurable. Let's say every minute or two or whatever it is. And it gets back a response. If the central command system has a need for data, it will send the start and end date time of the data that it looks for. I got some feedback from the guys at the MIT Haystack on how to do this with digital RF, where I can inquire as to what data we have already saved on the system that was in that time frame. And now I've got the code working to identify those files and compress them using tar. And then tomorrow I'm going to get it working where I can upload to the central system. Now I'm working with a simulator of the central system. The central system is being coded by our students who are away for the summer. So we'll probably have that in October, November timeframe. But in the meantime, I coded up a quick little Flask app that can stand in to just do these simple commands that runs on a virtual machine running on this Windows box over here. So I've got all the different devices running on the local network. So anyway, so making progress. By next week, I should be able to report that I'm able to upload data, selected data from the ring buffer, and push it up to the host. I'm working with John Gibbons at Case Western Reserve on the issue of naming conventions. Now, digital RF has a very fancy directory structure that is not easily compatible with the very straightforward naming convention that Case Western is using. So we're going to have to figure out something on that. But I think what we might do is something along the lines of the following. We'll use their naming convention for convenience to name the hierarchy of the digital RF stuff that goes below, so that you can identify, the human can just look at the directory name and identify what's in it, and maybe use some aliasing. One of the things is that the Case Western Reserve system, it just does one band at a time, whereas with the Tangerine, a given digital RF file will have all the bands that Tangerine is monitoring, up to 16 of them. So it doesn't make sense to try and put all that into a file name. So anyway, we're working that out. So, but anyway, we have been quite busy on that. So back to Ned.
Well, fine business, Bill. Next on the list, we have Veronica. Go ahead, Veronica.
Hello. Well, the last week I've been doing a lot of reading, and I'm still pretty new to this, so I'm a lot of watching YouTube videos to learn how to do things. But most recently, I've been working on making some graphs that show the relation of sunspots through time from data collected from 2018. Yeah.
Well, fine business. And next on the list, we have Nathaniel. W2D...
W2NAF.
NAF. I
Thanks.
can't see all the call signs and stuff.
That's okay. Thanks, Dave. Yeah, it's been a busy week for me, as always. So, yes, I have been working with students like Veronica and postdoc Dev. And Veronica has now got to work with Dev a little bit. And Veronica, that data that you're starting to work with, do you see Bill AB4EJ over here? Yeah, him.
Oh, yes, I see.
Yeah, he's the one that sends me the data.
Okay.
So the data that you get ultimately comes from him, and he gets it from other places. But let's see. And so, yes, Bill does all this data gathering. And I did download all of the 2019 data, Bill. I have dechunked it. I need to plot it now, but I have it downloaded and dechunked. So maybe we can talk to you about getting some more of the back files in that same format, because I think that's a very usable format. Let's see. And then so the big news for me is I'm moving tomorrow. So Rachel, Anthony, and we are moving to our new QTH tomorrow, our new home. We already have a G5RV Junior hung up on the property. So Dr. Declan Mulhall, another professor here, helped me hang that a couple days ago. And so we'll be on the air shortly. And we still have, I think before we get the ham radio station set up, though, they're going to be refinishing the office. So got all sorts of things like that. I'm also getting ready for the NSF CEDAR meeting, which is going to be June 22nd. And that's going to be virtual this year. Okay. Oh, and we ordered a USRP. And so we're going to use that. So Dev is going to start collecting oblique ionoson data and start working on how to process that. W2NAF back to net.
Well, fine business. Next on the list, we have Tom, an N5EG, right?
Good evening, Dave. Good evening, everybody in the group. This week I've been working on writing up the as-built cross loop antenna, and I made a modification to it to improve the sensitivity. The difficulty is now I get 5 volts peak to peak out of the preamp from local AM broadcast station. And the as-built was optimized for dynamic range, and it was real good. It had a very clean response and wasn't bothered. A difficult situation, I've got 3 AM broadcast stations located just under 1 mile away, running 20 kilowatts, and they're all triplexed onto the same one transmit tower. And so my LC notch filter can take out 1 of the 3, but it's not enough. And so I'm worried that this may be a problem that we have to compensate for ham size people in really bad locations. And so it's a fine trade-off between overload resistance and being a totally deaf receive antenna, or having good receive sensitivity and spurious byproducts absolutely all over the HF spectrum. So a little bit more work there. David was real kind to send me information about the preamp that he and Mike Trimpe have been using. I haven't had time to digest that, but I'm going to try to put that together. I received a bunch of requests, both on list and off list, for design objectives for the cross loop receive antenna. Unfortunately, many of the requests are quite mutually contradictory. And so I think we're going to need to figure out some kind of a requirement setting, go look at what science we want to do, prioritize the science objectives, and then go figure out what's the right kind of receive antenna characteristics to perform that science first. So I suspect we're going to be into that mode of operation here too long. Before we get there, I'll at least try to document what I've got and sort of explain some of the trade-offs. So back to the group.
Tom, I have a quick question. Does your Metaset have one of Graham's Alex sets?
Yes, it does. I have an Alex filter in front of Hermes.
How well does that cover or take out the AM broadcast of your HPSDR?
It does. There is a 1.5 megahertz high pass filter mode in the receiver on Alex, and that knocks down the AM broadcast quite a bit, but that's knocking it down after the preamplifier for the antenna. And by then, all the intermods in there. I put a step attenuator between the antenna and the receiver, so I can take down the output of the antenna. But for every 10 dB of step attenuation, all the intermod products come down exactly 10 dB, which means it's not the receiver overloading, it's the preamp in the antenna.
I remember Graham saying that he was within a mile or two of some 50 kilowatt AM stations in Austin. So
yeah, if there were no active devices in front of Alex, that would help quite a bit. And so the problem I think we're going to be faced with is one of how to knock down AM broadcast stations in the preamps somewhere. So to me, that may be an issue. I may be a good test bed in having a truly terrible location.
I got a stupid question. Is it possible to put the filter before the preamp? Yeah, but put the filter right on the antenna?
It's possible. I think we want to be able to have an antenna that operates at frequencies below the AM broadcast band as well as above the band. And so the question is how best to do that. My current notch actually is inside the preamp, so I don't mess up the antenna impedance feeding the preamp at any frequency range. And so all I need is a triple notch or maybe a suck out filter or something. I'm not sure. The tunable notch works real well. I can take one of the 3 AM stations out real easily just by tuning the notch, but it still leaves the other 2.
But you can't adjust the width of the notch though, I don't suppose.
To get a notch that's deep enough to be useful, it's pretty narrow in the AM band.
That's a challenge.
Yeah, it's a tough problem. The good news is at least I can document this hopeless situation. Whether we can address it or not, that's to be seen.
well,
No, I mean, and you're in a particularly bad spot. I mean, certainly other people could be in a bad spot too, but it is a sort of thing whereas if your station, if you needed to put a filter ahead of the preamp in just band pass like 3 to 30 megahertz, that could be okay for your station, but that may not be like standard practice. That would be for people in a similar situation, right?
Yeah, exactly. That's one of the key things is I think we're probably going to have to go through the process of determining the science we want to do, figuring out what the requirements for the antenna are going to be, and then try to come up with a set of requirements that we can actually go fabricate and build.
Yeah, this is also a good reason. I mean, certainly for a lot of the HF work, doing 3 to 30 megahertz would probably be okay. Especially doing work with like the sweep ionosons and WWV and even monitoring. We're doing a lot of work just looking at FT8 spots and the RBN and stuff like that. But then this is also a good case for building a separate VLF module, because then you could have the response just focus on that lower stuff, and again do a low pass filter to eliminate the AM broadcast.
Yeah, I haven't looked in detail. I suspect that a good preamp for very low frequencies probably has quite considerably different characteristics than one that's good in the HF range. Um, uh, David may have more information there. I think he's got some practical experience there that I don't have.
Yeah, and there's a lot of people out there that have a lot of practical experience with VLF stuff. I mean, there's quite a sizable community of people who are really into that.
Yeah, well, the good news is if none of this works, I will have a source of free electrical power.
Well, that's good. There's always a bright side, right?
But let's go on. Next on the list is Mike, AA8K. He has a wonderful aurora behind him, so it makes you look like you're kind of holy or something.
I am just an observer.
Anyway, thanks, Mike, for posting the TeamSpeak sessions. Hopefully this Zoom works well for you as well.
Yeah, I'm recording the audio. Is someone else recording the
I think
the Zoom record?
I think Nathan is.
Yeah, I'm doing
Nathaniel.
Zoom record to cloud. So when this is done, I'll just send Dave Larson the links, and he'll be able to either download the video or post the link to wherever he wants.
The Zoom record is far superior.
It's nice and easy.
Well,
Sorry
thank
I was
you.
late. When I started to join the Zoom meeting, it said I had to upgrade my Zoom software to join this particular meeting. Okay.
Well, thank you, Mike. And next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Okay, good evening, Dave. And you can hear me okay?
Yes.
All right. Well, thanks for running the Zoom session too, and thanks to Mike for doing the recording. It's always great to have recording for posterity so we can go back and look at all the great things we did in retrospect, right? Anyway, this week has been kind of a problem-solving week. I did get some answers from Altera on the ticket I filed. Turns out that the requirement for the termination resistors is a recommendation and not a requirement, which is be nice if they say that in the guide instead of saying it's a requirement in one place and a recommendation in another. So, because I was always been of the opinion that it would be much better to have nice short traces between the RAM and the FPGA with no terminator than to route it all around to get to a terminator and double the length of the traces. So, so it looks like we're going to do it without terminators. The next thing is that the speed grade that they required was the -6 speed grade, and there's no -6 speed grade in the book, so I can't buy one. So if with the -7, it doesn't meet timing for the RAM. So come to find out that there is an I6 part, industrial temp part, which actually is better for us because it has a wider temperature range. The only problem is wider temperature range means more money. So I'm really after these guys to give me a good price on this part. So we're going to see what's happening. I6 is the fastest, widest, fanciest part in the Max 10 series that they make. So they're going to they're going to be proud of that one. So we'll see what they can do for price, because really trying to keep the BOM cost under $100, and the FPGA is the single most expensive part. So it's the most critical one to keep the price down on. And then the jury is still out on the on-chip termination. I don't think that the FAE or the factory person understood my question, because the FPGA has two different types of termination, series termination of the high-speed lines to the RAM. It's called OCT, on-chip termination, and then they call it ODT, which is on-chip dynamic termination. And the explanation I got was that silicon resistors are really hard to make with good tolerance. So what they do is they dynamically adjust the value of the resistance based upon a fixed resistor that you place on a pin. So they send some current through it and they measure that resistance, and they try to make their resistors match that particular value that you put on there. So if you want a series resistance of 40 ohms, you put a 40 ohm resistor on this special pin. and then it adjusts theirs. And the table that I've seen is with the ODT, the on-chip dynamic termination, you get about plus or minus 20% tolerance. With OCT, that is with no comparisons or just turning the fixed resistor on, you get plus or minus 50% in value. So plus or minus 20% is a lot better, but maybe 50% is good enough to run the DDR3. The problem is that the termination resistor that they use to measure is in a different voltage bank. So if I use that resistor to set the ODT, then all the pins in that bank, and there's like 61 of them, all have to be run at 1.5 volts, which is the voltage that the RAM is run at. So I have to basically sacrifice about 60 IO pins to do that. And I really don't want to do that because I've got things that I need to connect them to. So the jury's still out on this. I'm hoping that we can make it work without having to use ODT. But it seemed like when I asked them, can I just use OCT, I got an answer back that said, well, the ODT part is on the RAM end, and it does that inside the chip. So I'm still a little confused. So we got one more go around before we figure out how we're going to be able to do this, and then we're going to just blast through just finish up the data engine and get it going. Those are the last two issues that I have. So anyway, that's what's been happening this week. Back to you, Dave.
Sorry. Getting used to the new software. Next on the list, we have Alan N5PA. Go ahead, Alan.
Okay, you got me now?
Yep.
Yeah, I was a question for Bill. I'm a retired IT executive and used to using very large databases, and I'm just wondering if the guidance right now is still going toward Hadoop, or have you made that decision yet?
I'm sorry, I didn't understand the question. Say again.
Are you still planning on using Hadoop for the back-end database?
For the back-end database of the Tangerine, you mean?
No. For collecting the data there at UA.
Well, Hadoop is one of the candidates, I guess you would say, but figuring that out is pretty low on the priority list right now. So if anybody has any suggestions, I'm all ears. Right now, all I'm thinking to do is just put all, I don't know, several thousand files out there as serial just sequentially searchable CSV files in a rational directory structure, and then make the whole thing publicly accessible. As far as doing, well, why would you use Hadoop or something like Hadoop? Is because you want to do a lot of analyses and you want to do them quickly. Mm-hmm. So far, that has not been one of the design criteria or requirements. Generally, people want to sit down and do a fairly leisurely analysis where they have time to download a terabyte of data and then search through it. You would use Hadoop running on one of the cloud systems if you're going to use the data a lot. So far, there's really only been a couple of people who have needed to look at the data. I mean, what do you think, Alan?
Well, I mean, yeah, it depends on how much analysis you want to do. We had a lot of users that were analyzing data so very heavily. So, we had, very large servers with, originally we were using Oracle, and it wasn't, performing well enough for us when we went to Hadoop. And, that cured most of our problems, but it was the end users ended up with having to learn a new skill set also. But if I understand right, you're going to push the raw files from the Tangerines to your servers. Is that correct, Bill?
Right. Now, don't confuse this. What I was just talking about in my previous comments was spot data.
Oh,
Now
okay.
we're talking about Tangerine data, which is a completely different kind of data. The spot data is observations of I heard a certain signal. I just heard it. I mean, I know the frequency of it, and I know the lat long of the sender and receiver. So that's the spot data. That's what we're talking about Hadoop for. Now, the Tangerine, now we're talking about signal data. It's a whole different ball of wax. So if you want to discuss that in detail, we have to schedule a whole separate Zoom meeting for it. I don't want to. It takes an hour just to get to do a base point of discussion on that. I don't want to take up our whole
Yeah.
Zoom meeting with that. So, but we can do it if you like. I mean, I'm always looking for ideas, but on the Tangerine data, it's going to be cross-referenced with good old relational MySQL database, and then the files will be accessible, and how we're going to analyze them, we still have to talk about with the science users.
But you're going to basically post-process the raw data from the Tangerines into the SQL, MySQL.
Well, it depends on what you mean by post-process. All we're going to do is in the SQL is keep a cross-reference of the files.
Okay.
That's all.
Okay.
But if you want to analyze the files themselves, you have to get those files and address them with signal processing logic. So.
Okay.
Anyway, I mean, if you want to go into it in more detail, don't hesitate to contact me offline. This is pretty much all I'm working on now. So.
Okay. I'm not too far.
I don't think, you can correct me if I'm wrong, but I think at this point, like, Hadoop is really not the right tool for what we're trying to do. We're mainly trying to get the data into one place, and then we'll make it available for analysis afterward. Whereas Hadoop is really supposed to be, doing MapReduce reduction on data in place wherever it's located. I think it's a slightly different need.
Yeah, I mean, if we're going to talk about Hadoop, we would use that for the spot data. The data coming from the Tangerine, that's a whole different, completely different.
Right, I agree with that.
So just as an aside here, I've just deployed, for my Whisper daemon project, we're now cloning the whispernet.org spot database in real time and providing a public interface. We're using the timescale database, which is a time series optimized database, which we're getting 100 millisecond response times when the SQL, the WhisperNet is taking seconds and sometimes minutes to return. So if this is relevant, go to my whisperdaemon.org and you'll see a guide tutorial, public access. You can do full-on SQL queries on the Whisper, all the full-on spot databases. We have some additional tables for other things as well, but just if you're, if that sounds like it's similar to what you'd want to do, I'm very, very pleased with timescale. I was really impressed. We tried the other real-time, time optimized series database. It's called Influx. We tried that, and it caught itself in conniption fits after a day or two of data, whereas timescale just scales beautifully. So.
Okay.
Well, we still have other people to introduce, so let's get on with our list. Next is David in N1HAC. Go ahead, David.
Hello, all. Interesting discussions in several different directions here. First, I'll talk to the loop antennas and the problems that Tom is having. We often have that same problem because we're trying to pick up similar frequency bands, but luckily so far we've had just like one station nearby. Anything from a kilowatt to 50 kilowatts, 2 to 5 miles away. And a single notch at the loop before the preamp does work. If we have a single loop, we just null it. But of course, with crossed loops, you don't have that advantage. You can get 3 dB down if you orient it crossways, but that's not a whole lot. So yeah, we've experimented with notches, single notches. I did mention to Tom that if we want broader band, we have done 2 notches, stagger tuned, but I haven't experimented with 3 notches, widely separated frequency. But there's no reason it couldn't work. What it is the amplifiers that we do actually will load the loop with essentially a resistance that is tailored to the inductance of the antenna and the bandwidth that we want to work with. And it often is, and usually is, on the order of like 30 ohms or so. Some of our higher frequency ones, I think it's a bit higher, but in most of the that handle down in that band, it's about 30 ohms. So it's actually very convenient for development because it's very close to the 25 ohms that you effectively have if you're putting a signal generator into a analyzer of some sort. And I just kind of tweak it until I get it to work right. There are the various parasitics and all, but I found for a Q of 10 works very well. And we've needed to implement those at various sites on our AM Doppler project because we're trying to get distant signals with receivers that are, as I say, within 2 to 5 miles of existing stations. And also, as such, being that it's working at essentially a resistive level, I don't see why a band stop filter couldn't be designed. That we'd have to experiment a bit, but I'll bet it could be made to be effective. And I know on the other hand, I know of some good band stop filters designed for 50 ohms. So the designs are out there. I've got ones that are both knock out everything below. They're basically a high pass filter and pass 160 meters and above. But I also know there are AM band stop filters that also pass VLF. So there's no reason that we couldn't knock out the AM one way or another. It might have to be at the second gain stage, between the first and second gain stage instead of right at the antenna, or we can do some at the antenna and some in the middle. We've done that before too. In Greenland, we had actually a non-directional beacon that was just a couple miles away that we had to notch, and it was loud, and we did 2-stage notching on that. So there are ways around this. The other thing, of course, is you just make a really high dynamic range amplifier, which there are good instances. And actually the Trimpy design uses op amps, so we usually feed it off of 8 volts just because we don't need a wide dynamic range, but you can run it off much higher voltage if you need to. So Tom said he was getting 5 volts out of it. That doesn't scare me really if you have enough headroom. You can filter that later. The other thing I was interested to mention is this termination with Altera, and man, that 50% of that's pretty ratty. I can't believe they even advertised that. But my question there is this a point-to-point signal, or is it a bus-like signal that's being terminated?
Well, it depends. If you have multiple RAM devices, then it's a daisy chain. But since we have only one device, it's point to point. So I
Yeah.
think putting the terminator on it will make it worse than you're going to gain by putting the terminator on it, especially since it's terminated in the devices.
Yeah, well, series termination for point to point is very effective.
Yeah, and that's
And-
what they're using.
Yeah.
Yeah.
So, you know, it might
But
just be a
if-
matter
if-
of putting
yeah.
some small resistors in the way.
But 50% is pretty ratty, I agree.
Yeah,
I use 1% myself.
right. But yeah, even you know, a SWR, so to speak, of 1.5 to 1 doesn't do too badly for overshoot, but you still should be able to get fairly close. And I don't know what the output impedance of the FPGA's outputs actually is, but you can tailor the trace impedance to.
Yeah, and you can tailor the rise time and the drive strength. So yeah,
Right.
use the output impedance. They're claiming we should use 40 ohms for this, and I don't know where they get that, but that's for DDR3.
Yeah.
It's pretty much a standard. So
Yeah. But anyway, I have some experience with termination, so if you want some help with that.
Well, what they really say is that, well, to do it properly, you should simulate your board layout.
Well, yeah.
You should, but I don't work for Intel, so I don't have access to that kind of software.
Yeah, well, they terminate it with put actual surface mount resistors in there, and then you just test it, try it.
Yeah, but I still say I would much rather have, you know, a 1/10 of an inch long trace between the two parts than a 2/10 of a long trace with the terminator on the end to try it. And that's it's going to make it worse.
Well, yeah, if you get a short enough trace, you don't have to worry about it.
And there's 36 traces that we have to do this to, so it's not pretty at all.
Yeah, so what's the rise time and what's the trace length?
Well, the trace length we don't know until we actually lay it out, but it's probably going to be on the order of a couple 1/10 of an inch, not much more than that.
Oh, I wouldn't even know.
Rise time is 100 picoseconds. It's very fast.
Oh, wow.
So maybe 200.
Yeah.
So.
Yeah, well, at a nanosecond a foot, so you're saying about an inch would be the rise time effectively.
There's no way that we're going to have traces that long.
Right.
Unless we start putting terminators on them.
No, if you can get it really close, then you really don't have to worry about it.
Our layout guy is really good. So we'll put the memory next to the, and all of the memory connections are on the one side of the chip of the FPGA. So we're going to put the RAM on that side, and then the traces are going to be minuscule.
Yeah.
So.
Well, it really comes down to layout. If you can lay it out tight, there's a lot less problems.
Yeah. And the thing is that I cannot find a single reference design, including the ones designed by Intel, that use those termination resistors. So
that doesn't bode well.
That tells you something, doesn't it?
So I would like to call on the other people that haven't been introduced.
That's what I got. Thanks.
So next on the list, we have Victor. Do you have any comment? We just want to introduce everybody.
Oh, hi. My name is Victor. Recently graduated as senior from the University of Scranton.
Okay. Nice. Hello. And then Elizabeth, are you there? Unmute your mic. Do you have anything?
I'm here. I have actually questions. From my last meeting that I had with Tom, with Dr. Bering, I don't know if you remember, Tom asked if we had a backup plan for our experiment. And since he said that a lot of the power consumption, the HF will be very, will make the payload very heavy. So it's probably not going to be feasible to fly it on a balloon. So my team and I decided to start looking into building one that will actually be feasible to build to fly it on a balloon. So my question is, how hard will it be for us to build an HF receiver? When we told Dr. Bering, who is our PI, he was kind of hesitating, to it's not feasible for us to build it because I think we don't have enough time. But we still want to kind of give it a try. I just kind of want to know, are we being reasonable with this? And if it's not reasonable, will you guys be able to help us or build it for us? How will that work? Or
I have a suggestion. You might be able to, we might be able to rope in the Case Western Reserve University people on this, because they've been doing a lot of stuff with very small, very low cost, very lightweight equipment, and they might have a solution that they can point you to. So we might hook you up with them. Just a suggestion.
That sounds great.
You said build a receiver.
Another suggestion might be to look for a commercially available receiver. Rob, I think, has got some experience there.
Okay.
Yeah, if you got budget, yeah.
We have $3,000.
But you were talking about receiver. If you're talking about a payload that you're going to fly, isn't that the transmitter that you're going to fly? And the receiver's on the ground? Do I have something that not right?
Well, we want to have your receiver on the ground and fly another one.
Okay, but it's a receiver you want to fly, or you want it to listen to the balloon with the ground station?
We thought about flying a receiver.
Okay.
To compare the two?
Yes.
Okay. So you fly the receiver and then do it and record what you received? Yes. Oh, okay, okay.
We have a VLF as well. So our initial project goal, science goal was to measure both, compare VLF and HF frequencies on the balloon.
Okay, I was under the impression you wanted a transmitter. So for a low power, low cost receiver, low power budget, have you looked at the SDR stick HF1?
Yeah.
No, not yet.
It's take a look. I'll post a link over here in the messenger. It's very low power. It's just a receiver, so it's no transmitter, but it's very low power and it's very small and light. So it might actually do the job for what you need.
Mm-hmm.
And if not, was it Tom? You suggested there's lots of off-the-shelf ones that might be suitable for that.
Is that it, Elizabeth?
Yes, that was my question.
Other people that we haven't called on. Orville, N8WQ, are you there? He's muted. How about Dev? Dev, are you there?
I think so.
Okay. Any comments?
Yeah, I've been listening through the introduction and many ideas on many topics. I personally moved from Florida to Scranton last week. I drove on the highway, and now with Professor Nathaniel, we're working towards building a receiver, SDR receiver, to receive chop ion Sunday oblique signals here in Scranton. And we'll be trying to receive the signals and try to process those signals and see what good science questions can we ask with the signals we possibly would receive. So that's the line of thinking we currently are pursuing. Thank you.
Very good. And Scotty has posted a link to the SDR stick. Scotty, I have to mention another one is RTL SDR.
Yeah, you're exactly right. You're exactly right. And that's very inexpensive too.
Yeah, this is like, I don't know, what is it? Tapper was selling them for $25 or something.
Yeah.
Yeah, it only goes down to 24 megahertz though,
I
unless
know
you go
that's
into
the
the direct
problem.
sample.
Yeah, this one, the HF1, is a direct sampling. It goes up to goes from 100 kilohertz to 30 megahertz. Samples at 80 megahertz. It's a 14-bit ADC. But you can get the it marries up with an P micro SDK, but you can get the power budget for one of these easily under 500 milliamps at 5 volts. So it's a lot less than what we are going to draw. And if you only need to receive, might be a good solution.
Yeah.
Other people, we had Rob, AI6VN. Go ahead, Rob.
Hello, everyone. I think you've heard my summary earlier, working on the database aspects of this. We have about 25 Kiwi equipped sites now worldwide who are contributing not just spot data, but noise level data on, typically 7 to 11 bands. So we are creating something of a database, queryable database, and starting to do some investigations and studies based upon that information. So that's the primary area of my activity. And as I say, yes.
Is that whisperdamon.org your main website?
Yes, that's where you can. There's a web page there that has leads to the databases. There's some real-time noise graphs, but really for serious investigation, you want to use do SQL queries using the the back end is Postgres, so it's full on SQL database.
Okay.
And then there's a Grafana front end, and there's some tutorials there that my colleague Gwen Griffiths has written. That there's some example, graphing tools, examples that graph data taken from our database and from our clone of the WhisperNet database. So there's we've done quite a bit of work in the last year. We're pretty much, that part's pretty much at the end. What I'm next going to work on is interfacing to other receivers. Primarily we're talking to the Kiwi right now. Most of these sites are Kiwi sites, and I recall, I think there's a talk about providing a SOAPy interface to the Tangerine. So if that will be available, then I should be able to talk to TangerineS. I mean, this system that I've constructed is, at the moment, primarily recording whisper spots and RMS and FFT based background noise levels. But the raw data is there. The IQ data and the wave file captures are there. So they other analyses could be done, incorporated into the system. That isn't my area of expertise. So if somebody's interested, that it might provide a useful framework for people wanting to do studies using TangerineS.
Yep. Well, very good. I did want to call Jay Schwartz. Are you there? No answer. How about Tom Yarnish? Are you there? I guess they're just listening. Well, we have Dan. He got to be last because he was right next to me on my screen. I keeping a list is a little harder here because people jump around which box they're in. Go ahead, Dan.
Yeah, Jay Schwartz is here. I just finally was able to get the computer to unmute me.
Okay, go ahead, Jay.
Hi, this is Jay, Whiskey Bravo 8 Sierra Bravo India, here outside Detroit, Michigan. First time joining the conference and just enjoying listening to everybody. Regarding the other comments that were earlier about having problems with high power commercial transmitters here in my area, I am in the heart of the area that houses most of the high power AM, FM, and television stations for the metropolitan Detroit area. If you draw a circle within about 3 miles to the west of me, there's hundreds of thousands of watts being shot into the atmosphere from those stations, all across the AM, FM, and TV spectrum. So being able to keep those out of anything would be very much appreciated. Okay, that's all I got. Back to net control. 7-3 to all. Whiskey Bravo 8, Sierra Bravo India.
Fine business. Tom, are you there? Tom Yarnish? Not hearing anything. We'll go back to Dan. Go ahead, Dan. I'm not getting a voice. There, sounds like you're there. Well, I'm going to give a small report for Dan, if he can't, while he's filling with his microphone. Dan did send both Bill and I a copy of his scripts for loading GNU Radio and FLDigi on Raspberry Pis, and making sure you have all the dependencies. So I will post that on the Tangerine website. I just got it this afternoon, so I haven't had a chance yet. Anything else, Dan? Okay. So we're open for general discussion here. We've used up almost our hour, but
We've had a lot of general discussion already, so that's good.
I got a question for.
I think I would like to make a suggestion. So maybe we should allot time for introduction, like in coming weeks, so that we don't spend such a long time through the introduction.
That is our normal process, is introductions and then have discussions on topics. Yeah. I try to keep people online, but this is a new platform, so.
Hey Dave, I think if you click on participants down at the bottom of your screen, you get a list of them on the right that does not jump around.
Okay, thank you.
It jumps somewhat, but a lot less.
I think we've talked to, at least given everybody a chance. Tom, I see you have a picture. Do you want to speak?
I just want to say hello. I logged in late and actually got the wrong machine up. It didn't have a microphone on it. So I'm really interested in the progress of Tangerine. I work with Rob a lot on his Whisper projects, and I'm fascinated by where this group is going. I was at the convention in Cleveland last year and found it fascinating, and I'd just like to follow along with you guys where I can. That's all I have to say at the moment, but actively working with Rob on these Whisper projects.
Well, I'm very interested, and I've been regularly transmitting Whisper, and you guys pick up my signal regularly.
Yeah, I'm KJ6MKI, and as I looked today, I was 19th in the nation, and it's pretty good because it's benign negligence. I haven't really tweaked the system at all. I got all kinds of noise problems, so I use I transmit on the UHF microwave bands, also on LF and MF, and once in a while I get around to the regular high frequency stuff, but I find that a little boring. But nevertheless, I'm really interested in the receiver technology and where all this data is going.
Yes, I'm KV0S. I'm on my work laptop, so it has my
You look like you're in somebody's basement.
Yeah, oh yeah, I am in my basement, and I use the Tapper Raspberry Pi boards for transmitting, and I have been pleasantly surprised how well 0.2 of a watt do around the world.
All of my work is done with the QRP Labs U3S. I have several of them here implemented in different ways, and I think they're fantastic.
Yeah. So any other discussions?
Yeah, Nathaniel, can you let me share my screen here? I'll show you the layout of the Pi Hat board, the magnetometer Pi Hat.
Yeah, go right ahead. You should be able to share.
Could I quickly ask Elizabeth, where are you?
I'm in Houston.
Ah, so you're with Professor Bering?
Yes.
Oh, say hi for me.
Let me see. Who were you? I
This
can't
is
see you.
David.
David? Okay.
David N1HAC. David
Okay.
McGraw. I'm at Dartmouth, and Gar's flown on some of our balloons.
Oh, okay. Okay, great. He has surgery today, so hopefully I'll get to talk to him the end of the week. But
right. But I had given him a list of some of the SDRs we've used, but
okay.
I guess they haven't.
Great.
Are you
been
posting
quite what he was looking for?
Excuse me. Are you posting some of these screens in the chat page so we can retrieve them later on?
All of these are being recorded.
Okay.
So you'll be able, the recording link should be posted to the TangerineSDR.com, and then you can just jump through and see it.
Okay.
That is our website, TangerineSDR.com. I don't know, this one's still like, hasn't been 100% finalized, or is it, Scotty?
What, this layout?
Yeah.
No, not yet. It's I've gotten some comments on it, which I'm trying to cogitate on and see if it's worth doing, making a few changes. But pretty much this would be producible here, this layout here.
Yeah.
One of the issues Dave brought up was these quick connectors. These are vertical ones, so you can mount cables in here. The horizontal ones, of course, you wouldn't be able to use this one here, the J11 one, because it would run into that one. However, these are all going to be optional because these are only used when you don't use it with the Raspberry Pi. So if you wanted to run flying leads over to some other kind of board that didn't have this 40-pin I/O connector, then you would use these. And so Dave's comment was that they would be, they're not possible to solder on if they're not mounted from the factory. And I don't necessarily agree with that because this connector and this connector are not mounted either. So you have plenty of room to get back in here. If you solder this one on first and then solder this one on, I think it's doable. And I think very few people are going to end up using them because most people are going to plug them onto a Raspberry Pi. So, and then the remote board does not use them. This is an RJ45 over here where the Cat5 cable comes in. So you take two of these, you'd plug one of them onto your Raspberry Pi, you'd plug Cat5 cable into it, and you use another one out in your backyard 100 feet away, and then you take the magnetometer board and you plug it on these two connectors right here. It's a little square board that goes on there. In fact, I think I have a diagram of it showing the outline of it. But what we try to do is, you see these components right here in the middle? These components are the exact components that are on the daughter card that you buy from P&I. So if at some point, and we're going to leave all these off the board, so at some point if P&I says, oh, we don't want to sell you that development board anymore, but you can buy the parts, we could still buy the parts and put them on this board, leave these two connectors off, and we'd have a magnetometer board still. Because I'm always wary of going to a developer, a chip manufacturer, and saying, I'd like to place an order for 100 development boards, please. And they go, what? Those are meant to be sold in onesie twosies, because even if you look on their webpage, they limit you to 10. So if you want to buy more than 10 of these plug-in boards, you have to call them. So at any rate, we've got belt and suspenders here for both, just in case. but these will just be pads on the board that will not be used for anything. And this is this is 65 millimeters, I think. So what, 2.5 inches? And it is about 38 millimeters this way. So it's not even 2 inches this way. So it's a very small little, kind of like the Whisper board that Tapper sells. And then up here is a local remote jumper. So you jumper this one way or the other, depending on whether it's the local or remote side. This address is not used because the addresses automatically correct themselves when you plug them onto the Pi. So if you have one on the Pi at one end and one with no Pi at the other end, all of the I2C parts will have different addresses already. So they'll be able to be talked to, both ends will be able to be talked to. So ironically enough, you could actually put a magnetometer on both ends of your cable and read both of them and compare them if you wanted to. So you could see, do I get a lot of interference inside the house? Is it really accurate? Is it not accurate? I don't know why you'd want to do that, but it's possible to do.
And that's actually kind of an interesting test case, right?
Yeah.
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 And it also could demonstrate to people the difference between why you need to put it outside. This is why it needs to go outside.
Right, because I copy my fluorescent lights.
All right. Now, I remember Phil Erickson posted one thing where he got some tips saying that the Pi hats could interfere with the magnetometer board. But I think that was addressed, or someone looked at that comment. Is that true?
Well, if you run the Pi hat with the magnetometer plugged on it and this board plugged onto the Pi,
yeah,
you got the Raspberry Pi like right next to your magnetometer, underneath it, right next to it. So that might be a problem. But in our case, you're going to unplug the magnetometer here and move it to the outside board. So there's no magnetometer next to your Pi. It's out in the backyard, 100 feet away. I think Jules actually has run it up to 400 feet away with SparkFun boards.
Yeah.
So you should be able to run them a goodly distance away and keep them away from all magnetics and transformers and power lines and all that if you have such a yard.
Mm-hmm. It's good.
And then we've got the little north indicator here, which I'm not sure why north is necessarily that way. This is the way it is. Since I didn't really want to bug the guys at P&I about all the orientation of their devices, so basically we just copied it exactly the same as is on theirs.
Okay.
So whatever the orientation is on theirs, whatever the markings are on theirs, that's the way we copied it, is the same on here.
Okay.
So if you plug the board on here, you're going to see a part there, a part there, a part there, right over the top of the places where ours would have been, and the arrow will be pointing the same direction.
Okay, that makes sense.
And
yeah, we don't want to get confused.
No.
So if you do have a question then, and you ask P&I, I mean, you're asking them about their own board that they made, not our layout. So it's, hopefully it won't be any problem. And we also have, even though their chip is temperature compensated, and I don't know, I mean, Hillman and Dave would be the ones to answer this, but we have the temperature sensor soldered down. I don't know which part it is. I think it's one of these guys over here.
Yeah.
So we actually can temperature correct anyway in the backyard, because likely if you live in Minnesota, it's going to be pretty cold in the backyard. So the temperature is going to be a lot different than what it is inside your shack.
Mm-hmm.
So you might need to correct the magnetometer readings based upon the temperature that exists at this board.
Yeah, cold in New Hampshire too.
Yep.
Yeah, cold New Hampshire and hot in Arizona. So it's, and then, like I said, this 5-volt connector here and the Grove and the 2 Quicks and the PMOD connector are all do not install. So they're options. And again, this address jumper is an option because it does automatic correction. But if you don't plug it into a Pi, then you're going to have to correct the address with this jumper. And we're actually a true Raspberry Pi hat because we have this U5 here is the serial PROM that makes us a real official Raspberry Pi. And this is the write-enabled jumper that we use to store the original whatever pattern we need to store into it that Raspberry Pi can read to prove that we're a real Pi. That's what we're going to put in the PROM. That's a problem for another day. And by the way, this PROM here in quantity, it costs 19 cents. So It's unbelievable how cheap this stuff is.
That's amazing.
It's only like a 4K bit prom or something, but it's only 19 cents. The
Yeah,
connector
Scotty,
costs more than that.
do we need to acquire any kind of ID if we want to be a Raspberry Pi hat?
Yeah, I don't know the answer to that. I know that at my company, we built a Wi-Fi module, and we had to get what do you call it? We had to have UIDs, they call them, universal IDs.
Yeah.
UUIDs?
Like UUIDs. They're like MAC addresses, and you make MAC addresses from them. So when we built the boards, we have to ensure that the MAC address is unique. So we actually went to the consortium in Europe and we bought addresses, and it turns out, I think we bought 16 million addresses because it was like, it was like $100 for 4,000 of them and $200 for 16 million. So it's like, that's a no-brainer. So if that's the case, I don't envision us building any other boards. We ought to be able to sublet a group from them for nothing and just put them in here if that's what we have to do.
Okay, so that's much easier to do than with USB devices.
Yeah, because you have to actually register as a vendor, right, to get a USB vid.
Yeah, you have to have a vid and a PID, and there's some database. We ran into that early on with Tapper and kind of gave up on it.
Well, to be honest, I have not checked into what actually goes inside that PROM. So I'm hoping that it's not anything that we have to get worried about. Although lots of people build quote unquote hats, but that aren't real hats because they don't have the PROM there. So we could just skip the PROM and leave it off. But I thought, for 19 cents, wouldn't it be nice to be an official hat and not have to worry about it? But it depends on what goes in it. If we have to spend big money to become a vendor, then we're probably not going to want to do that.
I do know that David and Holman are going to do some testing this week.
Oh, good. So
just to pass on.
Is Yeoman going to put one up at that park there in New Jersey, or is he still locked out of there?
I think it's Jenny Jump, isn't it?
Yeah.
Nathaniel?
Yeah, Jenny. That's right, Jenny Jump. And what's nice at Jenny, one other thing we already have at Jenny Jump, Ethan Miller K8GU already has a USRP set up there with cross polarized dipoles, active receive HF dipoles. So he said we'll be able to use that equipment that's already there as a test site for like doing ionosonde reception.
Oh, good. So we could substitute the Tangerine for the USRP when we get the hardware up.
Exactly.
Okay.
Nathaniel, where exactly is that? Like, in which location does Ethan have that? In DC?
No, Jenny Jump Observatory. It's a state park about an hour east of the University of Scranton.
Here in New Jersey.
In New Jersey, yeah.
Yeah, and we have one of our Dartmouth receivers there too.
Popular place.
Yep.
So anyway, this is what it looks like. It's up and coming, and that's it. Let's see now. How do I send the screen back to you, Nathaniel?
Well,
if you just hit stop sharing, you're good.
For time-sensitive people, we are past our allotted hour.
Okay, appreciate that. I'm going to need to jump out of here at this time. So this has been a real good session tonight.
Thank you. And just a reminder to everyone, we will have the Hamside Helicon this Thursday at 3 p.m. Eastern. I'll send out a link in a day or so with that information. And it's also posted on hamside.org/getinvolved.
Very good.
Okay, so Nathaniel, I got to become, oh, there it is, meeting controls. I'm looking for the meeting controls. I don't see them on my screen anywhere. So I can't unshare or...
What you have to do is you have to hit stop sharing. It's like if you go toward the top of your screen.
Okay.
There should be a little thing that pops up that's green, I think. And then you should see a stop sharing
I see icons, but I don't see.
There's not a red button.
Oh, it's over on that screen. See, I have 3 monitors, so it shows
Oh.
Oh, there's your
Boy,
problem.
that's a rough problem there.
I know I need a 4th monitor. That's the problem.
I'm sorry for your woes, Scotty.
And I know my monitors are too small. The biggest one's only 32 inches.
That's rough.
If you have to move your head to go from one side of the screen to the other, that's why I didn't see it. It's over there on that other screen.
That explains it.
Has anyone read the book Black Cloud by Fred Hoyle?
No.
Someone goes crazy with multiple screens. I'll just put that out there.
Well, if you ever read Dilbert, you know, the more screens you have, the more important you are.
Right.
Yeah. Scotty, were you able to find those Atlas radios?
I know right where they are.
Okay.
But I don't have my hands on them yet.
Okay.
This has been a funky week, but I am going to find them and send them. I got the addresses, and I will send them out to those people. So
Great. Yeah. So Victor is one of them. Victor's here.
say Veronica's here too, right?
And Veronica's here too.
Okay.
Yeah.
So
And
you
then-
3 then are going to
Yeah.
get. Okay.
And then I'm trying to figure out, you know, what a good starting antenna for both Victor and Veronica would be. Something that's modest cost, multi-band, doesn't require a tuner, etc. So I'm currently looking at possibly having them build a Wyndham, but then I'd have to get we have to get toroid parts for them and stuff like that. So
I tell you what, if you're only receiving,
yeah,
just put a 50-foot wire and throw it up in a tree somewhere. That's
well,
all.
that is certainly. So maybe we'll just do that. We'll do that and
It
call
works
it a
for me.
day.
It works. You know what I use in my building for testing all those boards that we sent out, over 4,000 boards. I clip a clip lead onto the compressed air copper piping in the building. That's my antenna.
Okay.
So for those
there you go,
of you,
Victor.
so those
Veronica.
of you that don't know, for the HPSDR board, Scotty and Dan tested every board.
So if you own an HPSDR board, it's got our fingerprints on it.
So which boards are you sending us? You're sending us the Atlas and
Atlas, Ozzy, Mercury, and Penelope. Not Penny Lane. It's the older transmitter.
all right. So hold on.
And I have sets of Alex filters too.
Oh, wow.
Both receive and transmit. And I don't think I have any cases. And I think Tapper sold out of those. But you could just set them on the bench and you can.
Yeah. So
but you're going to have to solder. So I know Veronica said she can solder. So Victor, I hope you're okay with soldering because there's some assembly required. Yeah. Okay.
So you said Atlas, Ozzy, Mercury, which is the receiver, Penny,
Penelope.
and Penelope.
And you'll need power supply.
And do I have LPUs? I don't. I have to see. Tapper has LPUs in stock. I'll go to the board and tell them it's for a good cause. Maybe we can get them to donate them.
Sounds awesome.
They're not very expensive, and I'm sure that Bruce would love to get them out of his garage.
Okay.
But I don't think we have any more cases. So, but that's okay. They run great sitting on the bench.
Can we 3D print cases?
I will tell you, the original, very first Atlas board is still running in Phil's shop with no case.
Okay,
Nice.
and isn't that the one they have the picture of on the website?
Yes, and he still uses it as his main HF radio.
Yep. So it will be a challenge for you guys to figure it out because there's a lot to learn on setting the thing up. But all the information is there. Dave's the webmaster for the HPSDR site. So if you can't find something, Dave's the guru. Will tell you where to go to read about it and figure it out.
Yes. It's openhpsdr.org.
Yeah, I showed the students the website earlier last week.
It's 10 years of accumulated information, so it is a whole lot.
And I was also explaining that in some ways this is the predecessor to the Tangerine.
Yeah, it is. We're trying to,
Yes.
we learned a lot from this project. We learned what not to do. We learned what to do. I think it's going to be a real refinement. I don't know if I told you this, Nathaniel, but we had the linear tech guys who are the guys that make the A to D converter on the Mercury board.
Mm-hmm.
And I asked them in 2016, I think. So that was 10 years after the Mercury board came out.
Mm-hmm.
I asked them, okay, today, 10 years on, what A to D converter would you use? What newer, better, fancier A to D converter would you use to make a high-end receiver? And they said 2208.
Wow. Same one.
Same one. They said they've been trying to make one that had more SFDR, spurious free dynamic range, and lower noise, and so far they couldn't do it.
Wow.
So maybe different now because it's 4 years later, but still that receiver, when you get it working, is going to be a very good receiver.
Yeah, that'll be really nice. That will be excellent.
And so the Dave, do you remember what there's a Hammond off-the-shelf case number that you could put the filter boards in?
I'm not sure.
I'm on the wiki.
Yeah, I think it is in there, the number.
It's like a 550 or a 5500 or something like that.
Yeah, the one I got it from Tapper, but then when I built my Hermes, I did order my own Hammond board for it. Oh, a Hammond box for it.
So what I was going to say is that even though you might have the Atlas board and the receiver and the transmitter and the USB board on a desk, what I did with mine is I just put rubber feet on the bottom, just stuck them on the bottom, and it sits right on the desk. But the low pass and high pass filters will actually go in a separate metal box that you can buy from DigiKey.
Okay.
So
that's great. That'll be really nice.
So yeah, hopefully somebody can get some good use out of them. These were the parts that I hoarded out of the build, thinking that I was going to have to build more test setups to build more production runs, and then we never did any more production runs. So they're still in the shrink wrap, brand new, sitting in the corner.
That's awesome.
From years ago. Oh, I hate to say it's been like 13 years now since we built those.
Yeah.
Oh damn, time flies, huh?
Yep.
That will be very good.
Yep. So the time pressure's on us. We have like 4 weeks left before we're kicked out, and there's tons of stuff to move.
Oh yeah.
It's pretty scary.
Are you trying to move it all yourself?
Pretty much, a little bit at a time, and moving a lot of it into storage and just tossing a lot of it. And I have an agreement with the new owner that whatever I want to leave, he takes care of, because he's going to come in and do a bunch of demo anyway. So he's going to have one of those big giant dumpsters.
Oh.
So just dump all the junk in it that I don't want. But I don't want to landfill stuff that's like electronic, because it's got, most of the stuff we do is no lead, but there's some lead in it. There's some gold in it for sure. It ought to be recycled. So we have a local Boy Scout group here that does electronics recycling. So I have a whole pickup load of stuff for them. Problem is, with this COVID thing, they've canceled all their meetings. So they have a swap meet once a month, but they haven't had one since February. So I'm hoping that the June one is going to be on. And so it's the third Sunday in June. So I'm hoping it's going to be on so I can hit them up with a whole pickup truck load full of stuff. They won't take CRTs though, of which I have 2 of them, I think. They're state of the art. Hey, I have a prom programmer that I can do windowed proms. I can program them. I have to keep a CRT to run with the PC XT because I don't have any other monitor that will run with that system that runs it.
Wow.
So it's really sad. But I don't know of any LCD monitors that do CGA. CGA resolution.
Yeah.
320 by 200.
You maybe could get a little little board from Adafruit that does that resolution.
I could get one that converts it to NTSC, and I could use a TV maybe.
Yep.
If I could find any analog TVs left.
I still have a few sitting around, but trying to get rid of them.
I have a 1952 Admiral sitting back in my shop that is.
Now you can donate that to somebody for a
Oh no! I'm going to fix that up and play video reruns of I Love Lucy on it or something.
Yeah,
that'd be nice.
You know, got to be some kind of antique by now.
I always liked it when the guy came over with his big magnetic coil and degaussed the screen.
Oh yeah, big loop like this big around.
Yes.
Hold it in front of the screen.
I'm seeing a ghost backplane in Michael's video there.
Yeah.
Do you remember tube caddies, the TV repairman coming into your house with a tube caddy, or going over to Radio Shack for tube testers?
Yes.
Oh, look at that! Michael has a homebrew case.
Oh, that is a homebrew Atlas case.
It's disappearing a lot. You need to
turn
cut your background.
All right.
Now, Scotty, your background is stable, but a lot of people, they have these ghostly. Is it a good green?
I'm unstable and I suck in all the instability that leaves the tangerine there. No,
I'm a blue screen and my shirt's kind of blue.
Oh, okay. I have no blue screen, but I have a high-end i7, so maybe that's the difference.
Yeah.
Processors that are a little bit slower have a lot of trouble with keeping the background up. It's like my head is, yeah, his head is there, but his blue shirt is gone.
By the way, these are the monitors I'm looking at right now.
All right.
You got quite a few.
7.
See, he has more monitors than I have, Nathaniel.
There.
And I think, isn't Jay pretty close to you, Michael?
I'm about an hour north of Detroit.
Oh, okay. Well, that's still pretty close.
So did you make that case, Michael?
Yeah, I bent the copper. I also have 2 Pandoras to house the other 2 Atlas boards.
All right. So Veronica and Victor, there's the preview of the Atlas backplane. What is that?
That's a filter off of a television transmitter.
That's pretty good.
I calculated it out. I think it's a 3rd harmonic. It's 1.45 gigahertz. But my feeling is we should filter it between the antenna and the amplifier to be the cleanest.
That reminds me, I was going to mention that the old wisdom used to be if you wanted a good AM or FM radio with excessive dynamic range, buy a Fisher or an H.H. Scott, because they were being designed right around the nexus in the Boston area of all the transmitters.
And you could probably still buy those at the flea markets, right?
Yes, indeed. But they were bulletproof front ends because that's the environment that they were designed in.
Oh.
And they're probably very heavy too, right?
What, the radios?
Yeah.
Yeah, they were pretty well built.
They said if you have a linear amplifier that you can lift, then you don't want it.
Yeah, yeah.
It's not big enough.
Of course, now they have switching power supplies, so
yeah,
that changes it.
So when I got my first ham radio, it was a Navy surplus steel case and weighed pretty near 100 pounds with lots of tubes inside.
Mm-hmm.
But
Yeah,
it worked well.
When I was a new general in high school, I got donated, I don't even know where this came from. It was an old AM broadcast transmitter. It was as tall as I was, and it used RK65s and PL200s, I want to say. Two are in the modulator and two are in the RF section. The thing, it wasn't a 19-inch rack. It was narrow and deep, so maybe 19 inches deep. But I remember my shack was on the 3rd floor of the house, and this thing weighed about 350 pounds. And I conned a couple of my friends. It took 3 of us to get it up the stairway into to my shack. And I still, to this day, I don't know why it didn't break through the floor, because it was. So I never did get it working because it required way too much more power than my whole station was wired for. But I got lots of spare parts out of it.
Yep.
So, fun you had.
Yep. So Dan, is your mic working now?
Hello, Dan.
He's shown as with his mic open.
It was suggested he try calling in.
I did see Veronica did that. Used her phone.
Yeah, I usually have trouble with my computer's microphone, so I call in with my cell phone, and this way I can hear everyone that's not lagging.
Yeah. Good idea.
So I guess Dan is either muted or are you there, Dan? Can you hear us? Make some motion. Hello, Dan.
Oh, no, there's a good tube.
833A.
Oh my God.
I think that's out of a Gates. They had 4 of these. 2 for RF and 2 for modulation.
Mine was QRP compared to that.
I think all of ours were.
Yeah. So Dan, I guess you're lost in the ozone here. We still don't hear you, but then you don't have your mic on. No mic.
I mean, his mic is on, but it isn't working. So anyway, unless there's anything burning, we're 27 minutes after the hour.
Only thing burning is the forest up here. No, it's not burning actually.
I think it was a good telecon tonight.
It was.
Hey, net control.
Okay. Yeah, we have a tropical depression coming, and they're predicting 4 inches of rain tomorrow.
Wow, in Missouri?
Yes, it's the one that was over the Yucatan, and it decided to come north.
Yeah, that's Cristobal.
Yeah.
It's going straight up the Mississippi.
Yep.
So I think New Orleans is going to get a double whammy.
Yeah.
A direct hit and then all the water coming down.
Wow.
So I don't know, but we'll see. But they claim it'll be sunny. It starts tonight and it'll be over by noon tomorrow. And it'll be sunny in the afternoon, they said.
Wow, after 4 inches of rain?
Yeah.
Whew.
But you never know. It can just swerve a little bit and you don't get very much at all.
Well, we're celebrating because it was only 92 today and only 97 tomorrow, and then it goes back over 100. So we had like 3 days or 4 days where it was under 100 degrees.
So you could actually go outside and be somewhat comfortable.
I took the antennas off the roof of our building at work yesterday during the day. Off the roof. Oh, it was awful. It was only 97, but it was awful.
Yeah.
That roof reflecting back up on you. I'm still not recovered. We just had I had an HF antenna and a repeater antenna there, and they were just bolted to air conditioners. It wasn't really hard, but of course the bolts were rusted, and I didn't bring the right tools up to get access to them, and it's like, looks like Dan is twirling his laptop around on the.
Yeah.
Why'd you have to take it all down? It was just they were falling apart, or they told you to take them down?
No, we sold the building and we're moving out. So we want to take the antennas with us. The butternut's not worth much. It's in the wind's pretty much trashed it, but the repeater antennas is still in good shape. So we're going to move that over to a friend's place and put that up. He's got a 50-foot tower, and he's on the high ground, so it'll be a good move for the repeater.
Well, I'm going to say 73.
Yeah, I think it will too. And thanks, Dave, and thanks everyone for coming. It was a good session tonight.
Thanks, Nathaniel, for setting this up.
You're welcome. I will send you the video link. It may get there tomorrow morning because it takes a little while for Zoom to process it. But once I get it, I will I'll probably just send it off to the ham site and the Tangerine lists, and then you can just copy the link on to the website.
Should we continue this way from now on?
I think this is good practice. I'm worried about DCC coming and knowing how to. I know it's different when a big meeting, but the more practice you have, the smoother it goes.
Yeah, because I guess a seminar is different than the meeting. The controls are a little different.
It's a little different. There's like an extra layer of complexity, but if you understand this, then adding that extra layer is going to be a lot easier.
Yeah.
And I mean, this is just so much better, I think, being able to see everyone's faces and also being able to share the schematics and things like that.
Yep.
I think it's easier for people to get it to work too, because we didn't have near the issues we had with.
Yeah, we always have microphone problems with TeamSpeak, and it just doesn't seem to be the same.
Except for poor Dan.
Yeah. Oh, sorry, Dan.
Dan's the only one with microphone problems.
He may have speaker problems. He looks like he doesn't hear us.
Can you hear us? Give me a gesture that you hear us. Okay.
Okay. Anyway, 73.
Okay. 73, everyone.
73, everyone.
73.
Thanks.
Thank you.
73, everybody.
Thank you.